Very good evening, one and all. Myself Jishnu, and Echo Foundations is running one internship program, and this sessions is as a part of our internship. And today we have a sessions that is called Introduction to GIS for researchers. And today's sessions is going to handle by Miss Hamsudani Selvan, and she's a GIS and remote sensing expert, and she's working in this field for more than 3 years. Today and tomorrow, she will be handling this session, and the first sessions will be mostly the lectures, and next day or tomorrow will be more on hand-on training, or you can prepare with your laptop or the QGIS software to learn along with Hamsudani. And thank you, Hamsudani, for joining us again. And this is going to be your second session, right? Second sessions with us.
Yes, sir.
Yeah, so thank you so much. And I believe that this will be an opportunity for our internship students as well as the uh, people who registered for this special session and to learn about the QGIS. And over to you, Hamsudani. Then maybe next 1 hour you'll be handling the session, and tomorrow also you will be continuing. Thank you.
Thank you, sir. Thank you so much for your introduction. And good evening, everyone. I'm Hamsatwani Selvan, and I'll be going to handle this session today and tomorrow for you. Let's make it most interactive one. I'll raise some more questions, some interactions during the class. I'll find some. I need you guys to drop some comments in the chat. Maybe mostly, if you have doubt, you can ask me at the end of the session. We'll go as an interactive session. Okay. So could you ensure that my screen is visible?
Yes, Hamsudani, your screen is visible, and I also spotlighted it so everybody can see it. Okay. Thank you.
Thank you. Thank you so much, sir. So again, hello everyone, and welcome to our today webinar on understanding GIS concepts and QGIS fundamental. So today is day one, the theory session, where you will build a strong conceptual foundation about GIS, what it is, why it matters, and how QGIS helps us apply these concepts practically. Then tomorrow, during the day two, the practical session, we'll actually open QGIS, explore the tools, perform basic spatial operations, and visualize real-world data. So by the end of this today's session, you will clearly understand what GIS means and how its importance, what its importance in research, different types of spatial data, the layout and main components of QGIS interface, basic data management, symbology, and analysis concepts. So these foundations are essential before you start working hands-on in QGIS. So understanding why we do something in GIS helps us perform the how more effective in practice. Well, so here is our agenda for today's theory session. We'll begin with an introduction to GIS, where I'll explain what GIS really means and all the basic things for research. And next, we'll dive into spatial data, the core of any GIS project, understanding the data types, raster and vector data, coordinate reference system, and common file formats. Then we'll move into QGIS interface and structure, exploring what this software looks like, the main panels, and how a typical project is organized. After that, we look at data management concepts, how to import, visualize, and style data layers, and metadata supports data reliability. Finally, we'll discuss GIS operations and analysis concepts, introducing basic spatial analysis, ideas like buffering, clipping, and overlay. These are the main building blocks of all advanced GIS works. So let's start by understanding what GIS actually is. GIS stands for Geographic Information System, and it's much more than just mapping software. It's a framework that combines data, people, hardware, and methods to capture, manage, analyze, and visualize spatial information. Think of GIS as a bridge between location and data attributes. Or data attributes in the sense data, what is happening in that particular location, that the metadata is often referred to as data attributes. I hope you all understand. It doesn't just tell you where something is happening. It actually helps us to understand what is it and why it matters. For example, imagine you are studying trees in a city. The spatial data would be the geographic locations of tree, their latitude, longitude values. That is called the geographic data. That is spatial data. Then attribute data would include species, age, or canopy size likewise. So when combined this in GIS, we can analyze patterns like which species dominate in certain zones or how canopy covers varies with temperature. So GIS performs 5 key functions. Let me explain that. First thing is capture, collecting data through satellites, GPS, or service. Actually, capturing is mainly referred as remote sensing, that collecting of data without any contact to that particular object, that is through satellites. Second thing is organizing data in layers and databases. Here starts our GIS. So first, capturing is mostly covered in remote sensing. GIS start from storing, okay, organizing data in layers and database. Then managing, that is ensuring data quality and structure. Each and every satellite data has its own resolution. This gives the quality of the data. Then analyzing, performing spatial analysis operations and statistical modeling. Now we have a data, a software, everything. But what we are going to do with that? So we need an output, desired output with that data. That is what it will be happening in analysis. Analysis. Then visualization. Okay, we had collected the data, stored it somewhere, managed it to some structures, analyzed it. Okay, all these things will be handled by GIS professionals. But end users need the real answers, where something is happening, what was the effect, how was the density, what is the temperature. Likewise, they need the end result. So presenting insights through maps, charts, and dashboards. This is what done in visualization part. It totally depends on the end users. Then each of these stages transform raw data into meaningful insights that can inform research and real world decision making. GIS helps reveal the spatial relationships. For instance, how land use affects the water quality, or how health outcomes differ by region. Recently in our COVID, we will know that some parts of India has affected a lot. Mainly China was the mostly highly affected area. So we know high, low. This is not what the end users need. They need the statistics. So that is what GIS is revealing to the world, the spatial relationship, the connection between the spatial data and non-spatial data, the location data and the attribute data. So in essence, GIS helps us move from data to understanding, not just tables. We are seeing it, we are visualizing it as the maps, better understanding dashboards, real insights like this. That's why it has become essential in almost every field, from environmental monitoring to urban planning and even in public health. So now we can see a small overview about what is QGIS. So let's now explore the tool that makes the most GIS work possible, mainly for students, researchers, and professionals, because QGIS is an open source technology. Okay, let me come to the point. QGIS stands for Quantum GIS, and it is one of the most powerful examples of how open source technology has transformed the geospatial science. It began in 2002 as a small project by a geologist who wanted a simple way to view the spatial data. So he did a great job. Today, it's used by governments, research labs, and universities worldwide because the outputs was also more accurate in QGIS comparatively than other softwares, other GIS softwares. So what makes QGIS truly special is that it's free, open, and community driven. You don't need costly licenses to perform high-end spatial analysis here. So here is the first question. How many of you have already installed or used QGIS? Have anyone? You can drop your answers in chat box just for a little interaction. No, okay, you guys are very new to this. Fine, then we'll explore a lot tomorrow, okay? That's fine, no issue. Let me say some more interesting things about what QGIS really has. The first thing is multi-format data handling. QGIS supports a wide range of data types. I'll explain this data type, but let you guys just remember all these important words, important jargons in GIS. So the data types were shapefiles, geo packages, TIFF formats, CSV, KML, GeoJSON. See, it's going there somewhere. So QGIS mainly handles a wide range of data types. So this makes it outstanding other than other GIS softwares. And even real-time web services, that is WebGIS, also possible in QGIS. We don't need to buy any high-end softwares. You can connect to a live map of rainfall, population density, or even elevation with just a URL. So you can play a magic with GIS in QGIS. Then extensibility through plugins. Lots and lots of plugins are available in QGIS. Plugins are like apps within the apps. Like in Instagram, we do have what we say threads, I think so. So that is app within app. It is connected to. So likewise, we have some plugins here. Some major important plugins are unavoidable plugins. I will list it down. Kindly have a note. We'll have a recap then. I'll just ask you questions. semi-automatic classification plugin. So that is SCP plugin. Semi-automatic classification plugin. This is mainly used for satellite image classification. Then I think these things will not be listed in the slide, but I've collected a lot for my database. So I'm sharing it. Then quick map services. That is, wherever you draw something, you're creating some data, you should know that it was actually placed in right location, right? For that, you need a base map. Wherever you start the cartography, that is map making process, the first step is to take a base map. Start with a base map. So for that, we have a plugin name quick map services. So we can connect the Google, Bing, OpenStreetMaps, everything to QGIS. We can view everything there. Then time manager, this is for animate temporal data. See the change detection in QGIS. How was the city in 2010? Then how was it as 2020? Likewise. We can just visualize it. We can't download it or we can't perform or get desired result, but we can see it. Then its integration with other GIS engines. These are also actually constituents of GIS on QGIS. So its integration where means QGIS works hand in hand with GrassGIS, Saga, and GIDAL. This means you get the best of both desktop and scientific GIS worlds all in one environment. Then again, if you are a developer, QGIS has place there also because it has Python and automation opportunity also. With PyQGIS, users can automate repetitive tasks, build custom tools. Even you can create a own plugin or integrate with databases like PostgreSQL and PostGIS. So let me give an example for this. A researcher can write few lines of Python to calculate NDVI for 100 satellite scenes automatically. So if you are making a change detection for more years or experimenting the glaciers, means it needs a more effective data, right? You can't perform NDVI for each and every satellite data that you are collecting. So you can automate that work. Then community driven it is. Yes, QGIS has a vast online community. The QGIS itself has own user manual that is more detailed explanatory. It has tutorials, documentations, user forums, and a global developer team. So you're never stuck alone. There is always someone who has solved your problem before. Here I bring a fact for you. Did you know that QGIS has been translated into more than 50 languages and is supported by volunteer communities from over 100 countries? So it's not just a software, it is a collaborative movement in geospatial world. So now let's explore how QGIS applied across real world research domains. That is what we actually need from environment to business intelligence. So let's see that. Now we know what QGIS is. Let's see how it actually shapes the research across different disciplines. So QGIS is one of those tools that you will find quietly powering thousands of published studies, whether it's tracking deforestation or mapping urban growth or analyzing disease outbreaks, wherever, whatever the spatial analysis have been done, there QGIS have been placed. It is unavoidable. Okay. Let's begin with a story from Kerala. Okay. A group of environmental researchers, so this is just to relate, that's it. Researchers want to study how some districts have changed over last 30 years. So they downloaded Sentinel-2 satellite images used QGIS to classify land cover and overlaid the district boundary and hydrological data. So within few days, they were able to visualize areas where paddy fields were replaced by build-up land, a clear indicator of loss of land. So that's the power of QGIS in environmental research. So you're not just seeing maps, you're witnessing the environmental transformation, the loss of habitat. So first thing is, as I said, the inevitable one is environmental and ecological research. So QGIS is heavily used in this particular industry domain. So let's see the tasks that can be performed. First thing is mapping land cover change. Whatever the project you have done, this will be one of the layer for sure. Then monitoring vegetation using NDVI, that is normalized difference vegetation index. So this factor, vegetation, will come even in agriculture also, even in urban growth also, how the land has been split out, everything. The NDVI and land cover is very important. Oh, sorry guys, I just didn't see. Please come again. Which you want again? Sorry, since I'm presenting the screen, I didn't see this chart. Uh, could you please mention which point I should recall? I'll recall after this slide. Okay. A semantic. Okay. Okay. The plugins. Okay. Just give me few minutes. I'll complete this particular slide and I will explain. Okay. Sorry, I didn't notice the chat. Okay, let's come to it. Now, we just see mapping of land cover change, monitoring vegetation, and again, assessing forest loss or wetland encroachment. The researchers can integrate satellite images with the boundaries to quantify the change over time. Let me give an example for research idea in this environment thing. Mapping forest degradation in your own places between 2000 to 2025. This would be a great topic for your research or your projects, whatever you want. You can explore it, learn it through this. Okay. Okay. Now I'm having a question. If you were analyzing water quality, what kind of spatial data would you combine? Would you use first? What particular data is an important data for analyzing water quality? What do you think? Just your views. It is not something you should say the right answer like that. Just for your knowledge. Temperature, that is also one of the factor. Anything related to hydrology, temperature was also a main factor wherever you are studying. But here we are handling dissolved oxygen. Actually, spatial data. You guys are saying the parameters. That was good. That was exactly right. The color, everything we will learn in the parameter. But I'm asking spatial data. That is, okay, let me reveal it. Like the watershed, I think all these terminologies were new to you. Watershed means the boundaries of the river line. Then main thing, rainfall zones, soil data. All these is a factor for water quality. So we need all these data as a layer. We will overlay each layer and then only we can get any map. Okay. Contour depth survey. Yeah. Oh, great. You guys have deeper knowledge. That's nice. Okay. Let's move to next topic. We have less time. So then again in urban studies also, QGIS is used to understand how cities expand and evolve. For example, researchers in Delhi used QGIS to map urban sprawl, and assess land consumption rate using a Landsat imagery. So city planners use it to identify suitable locations. This is suitable locations for new schools, hospitals, or transportation routes. Actually, this is called site suitability. When you are identifying suitable location for any particular building, that is called site suitability. These are some GIS jargons. Just note it down. Using spatial analysis tools like buffer or overlay, planners can see how close public communities are to residential zones, ensuring equitable urban development. So then in agriculture, it is used, the spatial data has a link with crop performance, like classifying the crop type using satellite images, mapping soil fertility zones, which crop is healthy, which crop is dried, calculating the NDVI for those healthy crops, then assessing the irrigation efficiency. They can also find the yield prediction now using precision farming, like integrating GIS with AI and ML. So we have an example, researchers use QGIS to compare NDVA values before and after fertilizers application. So find that productivity improved in certain plots or not, whether the fertilizer is effective or not. Hey, hurry, yeah. Okay, then health, demography, and social research also, GIS in health studies is growing rapidly. QGIS allows researchers to map disease outbreaks, as I earlier mentioned, visualize health facility coverage, and identify spatial patterns of risk. Which parts of area have been covered? What malnutrition affected by, maybe likewise. Then example, so during COVID-19 pandemic, several public health researchers used QGIS to map the infection clusters, travel patterns, and vaccination access. So see how it's growing. In social science, it is used to map the poverty mapping, crime hotspot analysis, and population density modeling. Each and everything I'm mentioning is one of the projects that have been done. Even you can do it for your own city or your village or your own area. The crime hotspot analysis is evolving every time. Even previous year you have performed crime hotspot analysis, but this year it can change. Some spots can change, some more changes can be added likewise. So think about your own field. How could GIS help answer your research question? Where, why, and how? Every research starts from these questions only no. So think how you can power your research using QGIS. So now we have see what is GIS. Okay, we can do all these analysis with QGIS, but how? To start over anything, any process, we need the data. And here, every GIS project begins with data. And in GIS, data comes in two main types. We are only handling these two kinds of data. That is vector and raster. Understanding this is the biggest step to truly think spatially. So let me make it more easier. Imagine you're analyzing a flood prone area in your city. So you are marking flooded locations, or you're marking flooded locations. You'll draw the river network, how the rivers are flowing, and you map the flood zones or the administrative boundary. So I said flooded locations, no? This particular vector data has the three major kinds of data. the subdivision. First thing is point. That is called the location, flooded location. Points means everything is points. The best example is when you open the Google map, you see the schools, the hotels, everything, the marks, locations, no? Those are points. Then the roads, the river networks, or pipelines, everything are lines. Then the administrative boundary, the city boundary, the state boundary, or a building, every boundary is a polygon. So this is what vector data is. It's all about shapes and their coordinates. Each and every point has its own coordinate, that is latitude, longitude value. Lines has collective coordinates. Then again, polygon have a set of coordinates with it. So it is all about the shapes and coordinates. So vector data is only the three things, that is points, lines, and polygons. Then you bring in rainfall intensity map. Now you should go back to your flood map. Okay, the problem, flood prone area. So now connect with the rainfall intensity map. It needs the rainfall. Only flood will come occur due to the rain. And now we are taking the rainfall intensity map or satellite imagery showing flooded pixels. That is raster data made of tiny grid pixels, each pixel storing a value of, in accordance with the rainfall intensity map, it will store the value of rainfall in millimeter or its reflectance. So mostly satellite images or not, raster means nothing great. Take your phone, in your gallery you have all the raster data, that is general images or raster data, but here it has the location and the specific value with it. In accordance with rainfall means it contains 1 point of rainfall value there. If it is a temperature data, the satellite image is a temperature processing means it has a heat value there. If it is something a DEM, digital elevation model, means it has the elevation data there. In the pixels, in each and every pixels, even in your own photo, when you keep on zooming it, the photo will start to break. That means into a small boxes that are called pixels. And in normal photos, it will be color patterns. But here is also color patterns. But those patterns will have location and particular value. So vector data represents discrete geographic features that have defined shapes. I repeat, vector data represents discrete geographic features that have defined shapes. In QGIS, these are stored as points, as I said, wells, schools, the station points, whatever it is. Lines means rivers, roads, and pipelines. Polygon is also like shapes. So each feature also carries attribute data. So it is not something like you in the point, it contains only the latitude, longitude value. It has the other data about the well. If it is located in this particular location, means whose well is this, how deep it is, when it was dug. Likewise, other data about the well is called attribute data. Data about the data, that's it. So there are various data formats for vector data and raster data. So first thing is ESRI shapefile. That is, if you are creating a vector layer, it will be created in this format only, .shp. This is one of the oldest and common vector format. It usually contains several files with it. .shp, when you are creating a single layer, it will automatically create multiple layers with that. SHP means it is for the geometry. Then DBF file will be created. That is for the attribute data. Likewise, database, small local database. Then SHX, that is for index. So it widely supported. Mostly all the polygon line, everything will contain this only. Then geo package is this modern alternative. So it stores multiple layers, both vector and raster. GeoJSON, this is for web application and data storing. Then KML, I think I have I've mentioned this in the earlier first slide, I hope so. This is a particular format for Google Earth. It is a 3D visualization of our globe. So KML is for Google Earth format. KMZ is the compressed version of KML. Then DXF, we don't often use this because it is a CAD format, but I have just taken this for a reference. GML is a geographic markup language. KML is a keyhole markup language. GML is a geography markup language. Then CSV we need for we need this for points. We will join this in QGIS. So there we need this. Then the raster data. So raster data represents continuous phenomena. Where I said vector data represents the discrete geographic data, raster data represents continuous phenomena. Things that were smoothly across space, that is like already I mentioned it, elevation, temperature, rainfall, or satellite imagery. Everything is a raster data. Each raster data is made up of pixels. You guys are very familiar with that. Now let me say the format. First and foremost thing, any raster data was only in this format, that is .tif. This is called GeoTIFF. This is the most commonly used raster format. Okay, sorry. I think the raster data format, vector data format. What was the table heading mistake? Sorry, I can't see what's the mistake. This is the format and it's the extension, type and description. Could you mention what was the mistake there? First slide. In this table or while I'm starting the first one? Introduction style, first and foremost, that you're mentioning.
The first one, vector and raster data.
Difference chart. Oh, I made. Oh, okay, sorry guys. Yeah, I made that mistake here because here I saw the raster and vector, so I made the same mistake here also. Okay, so if really it was a careless mistake, it should not be done. Sorry guys, really sorry. But you're all clear now. What is raster? What is vector? Any confusions in that? Yeah, you're clear. Raster means it is about the discrete data, points, lines, and sorry, again mistake. Vector means that is discrete data, points, lines, and polygons. Vector means you are creating. Raster means it is captured by remote sensing, satellite data. Even drone images will also come under raster data. Clear in that? Sorry, I will change it. Then the most commonly used TIFF. I came back. Okay, this is how the points look like in satellite images. Okay. Then IMG, here it is used in a specific GIS software. ERDAS Imagine is also one of the software. This is common in remote sensing. This particular format is common in remote sensing because it is capturing only, no. These are raw data. So this is more common in remote sensing. Many land use and classification maps are stored in IMG formats. This is also easily readable in QGIS. Here, you can see the JPG and PNG, but you cannot directly upload this file. You need the world file with this. So if you have a regular image plus the small world file, that is like JGW, PGW. If you have that file, it becomes a georeferenced. Georeferenced means the file, the image will contain a spatial data with it, that is location data with it. So QGIS can overlay it on the real coordinates. Next comes the net CDF, that is used for climate or time series data. I'm not much aware of this data. I have not used it earlier. Same wise, HDF is used in satellite data, especially in MODIS. This is a particular sensor and also other scientific sensors. So it stores, I think it's a hyperspectral data, large and structured data set. ASCII grid. So this is a simple text-based raster format. That is, each cell value is written as text. There we see values, no numbers like rainfall data. Here, this particular each and every pixel cell is written in text. It often used for elevation data or hydrological modeling. Really, I have not used all this much data earlier, but I've learned this. So remember, again, I'm saying a vector means points, lines, and polygons that you can create. Raster stores the continuous data as grids of pixels. GeoTIFF, that is .tif, is your go-to format for research or remote sensing work. Okay? Then if you are handling with climate-based satellite data set, then your go-to format will be NetCDF or HDF. Then here and now, till now, we have seen everything like what is data, types of data, everything. Next, let's understand how these data sets actually locate themselves on Earth through something called coordinates reference system. So once we know what kind of data we have, whether it is raster or vector, the next question is, where on Earth does this data sit? You have a boundary that is very well designed, correct boundary of your district. Whatever is your area of interest, you have the boundary. And you also load it on the GIS software. But you have to know the exact location, where is it? That is why I told you, that is why we use the base map. So for that's where CRS, that is coordinate reference system, comes in. If you are having a wrong coordinate system, means the particular shapefile will not place in the exact position in the base map. So let me tell this. Let me explain this more clearly. Think of CRS as the address system of the planet. Just as your home address helps others find us. Say, you will say, this street after this shop, behind this temple, we will say likewise. So CRS helps GIS software locate our data accurately on the Earth surface. So without proper CRS, even the most accurate shapefile might appear in the wrong part of the world. So, for example, I have my Thuthukudi boundary. If that's my native, if I placed it with a wrong CRS, means it will be showing somewhere in the Indian Ocean. That is what wrong CRS performs like. So the geographic CRS uses spherical coordinates, that is latitude and longitude. Hope this image makes you clear the types of coordinates reference system. So the first one is geographic coordinate reference system that uses the spherical coordinates, that is latitude and longitude, normal geographic coordinates. This is great for positioning. Then comes our projected coordinate reference system. This flattens the Earth using mathematical projection. So this is for measuring distance and areas. I don't know whether you guys are aware, But during my school days, this will comes in our geography. Ma'am will say like, when you take the orange peel, you can't flatten as it like a paper. There will be some cleavages. So the mathematical projection will help to clear all these cleavages in the projected coordinate reference system. So what do you think happens if two layers in QGIS have different CRs? Simply, they won't align correctly. One may appear shifted or distorted. So this is the common basic error I've done during my beginning time. The units for geographic coordinate reference system was degree, and the coordinate reference system example was EPSG 4326. So this will be displayed in the bottom of the status bar in QGIS. I'll show you tomorrow. Then the example for projected coordinate reference system is UTM. It will be dividing the whole earth vertically. So north zone, south zone, likewise it will be dividing. And the unit was meters or kilometers. Now, I'll say a fact. The EPSG code I'll mention as the example for geographic coordinate reference system. No, the EPSG code system is the global registry of the coordinate system. So QGIS uses these codes. Different numbers will be there. EPSG 4326, EPSG 32643 to automatically interpret and project your data accurately. Guys, you are clear on this topic? So now I'm moving to next slide. If you have doubts, kindly ping in the chat box. I'll repeat it slowly. Okay, you're clear. Thank you for your feedbacks. So this is the interface of QGIS. I just took a screenshot. This is how it actually looks like. Just take a moment. You just view all the numbers, what 1, what 2, what is 3. You look it. I'll explain. Just take a glance for a minute. Now I'll explain it one by one. So now we know the GIS data and its formats, real-time application, everything, CRS, everything. So here is the time to see the QGIS interface. Think of QGIS as your research cockpit. Every button and every panel is designed to give you spatial control. So imagine opening a blank QGIS project. So it will look like this only. The previous one, it like a loaded one. But when you're opening, it will look like this only. So here, first thing is browser panel. That is in the left side. Yeah. Is your storage shelf. You can reuse all the properties listed there. Then comes our layers panel, is your workbench. Then our map canvas is your microscope view. You can keep on zooming it. It is based on the resolution. So let's understand each tools one by one. First comes our menu bar. that is located at the top, and this is the brain of QGIS because it organizes the tools under various categories. There are lots of tabs in the menu bar like project, layer, vector, raster, plugins, and settings. In each of these tabs, there are multiple buttons are there. For example, in the project button, we have the open button, save button, new. Likewise, there is a list of buttons, list of options there, functionalities there. In vectors, there are a lot of functionality, geospatial functionality. Each and every tab has its own functionality. Then comes our toolbar. So there is nothing in QGIS without this toolbar, because the toolbar provides the shortcut icons for commonly used tasks like adding raster or vector layers, zooming in and out, selecting features, identifying attributes, measuring the distance area. Everything is in toolbar. Pan, zoom in, rotate, labeling, displaying the label, everything is in toolbar. See, the second row is the attribute toolbar. The third row is the vector toolbar. So you can hover your mouse over each icon. If you guys have QGIS, you can use it, or else I will show it. Then comes our, as I said earlier, browser and layer panel. Browser panel acts like a file explorer within QGIS with some internet access. It lets us access the folders, database, and online sources, the servers, GeoPackage, PostGIS, likewise. Layer panel lists all our added data sets, like all our vector data and raster data combined with it, our boundaries. We can change the visibility, reorder the layer, and go to the attribute table and properties by right clicking the layer. This is what we often do. So kindly make note of it. You will right click on a particular layer so you can open the properties and other functionalities for one particular layer. Then map canvas. This is the heart of QGIS where all spatial data is displayed. So you can zoom, pan, identify features, feel the real visualization. So layers are drawn in order, top to bottom, as in the layers panel. What you load first will be displayed first. So if you place the district boundary layer, everything here is a layer. Satellite image is a layer. All the vector data or raster data is mentioned as layer. So I often use this particular word layer only. Okay. So district layer above the satellite boundary means you can clearly see the administrative lines over the image. But if you keep the district boundary below the satellite image, means you can't see it, because what you place first will display first. So it will be actually in backend, it will be behind the screen likewise. Then our status bar. So it is found at the bottom of QGIS. So it shows the cursor coordinates. Wherever our mouse moves, it shows the coordinates in the bottom. Then the current maps scale. Then active CRS. I told you, no, it is in the bottom. So if you move over the map canvas in your location, it will give the geographic coordinates updating live. Even in your city, there will be different coordinates. No, it will be changing in live. So QGIS automatically reprojects layer on the fly when you work with different coordinate system. But you can actually set up project-wide CRS from this particular bar. Okay. Next comes our major part, that is setting a new project. So that's the QGIS main part. So each part plays its own role in exploring, analyzing, managing data. So setting a QGIS project, it's not just about opening QGIS. It's about building an organized digital workspace where every data set, output, and map has its own place. Imagine you're starting your change detection study for your area of interest. You have 5 satellite images, 2 shapefiles, and 3 output maps. If you don't organize them from the start, by day 3, you'll be asking which version was the final one, likewise. It will be confusing. So that's why project setup is crucial. It keeps your analysis clean, traceable, and reproducible. So make a proper plan for your any project and the file structure. So for that, we'll opening the QGIS. If you download it today, you can explore whatever I am saying, or else no issue. I will explain it tomorrow.
Hello,
So
Hamsudani.
there are various. Yes, sir.
Yeah, have you finished? Not yet, right?
There are few more topics. Okay,
Okay.
I'll just combine for tomorrow. No issue.
No problem. If you want to continue, then you can. It's fine. Okay. Yeah.
Okay.
Yeah.
Just few more topics, sir. Data management. It is actually. I'll just move to the spatial analysis. This is what the core they need. So I'll explain with that, and I'll explain the data management on the interactive practical section. So we have a look at data layers and maps and everything. So this is the time to learn how the analysis actually plays part. So here it is the process of combining the location, attributes, and the geometry to reveal the hidden insights. So the typical questions what we'll be asking, like where are the hotspots, which was the agricultural field. Likewise, these are the common questions will be raised. So nearly 80% of research data has a spatial component, meaning almost every discipline can gain new insight through this spatial analysis. So let me explain each spatial analysis to the vector and raster. How to perform the spatial analysis. First, you start with loading your own data, then add all the required data sets, that is loading your data, raster or vector. Then first and foremost point is to ensure their coordinate reference system. If it is misaligned, then the result will be inaccurate. The third step is here. See, whatever the process you are choosing, where it be vector analysis or raster analysis, you'll be choosing the processing. Then you go to processing. There you can find the toolbox. You will choose the right category in this. If it is for vector, we have specified geoprocessing analysis, or it is for raster, we have separate, or It is for network analysis, it is totally different. So you will process these things, then input parameters will be defined like distance or layers, it will be defined. Then QGIS automatically makes it the performance. It will give the input as our for that we can apply symbology, classify the results, make the real payment, the real process. So here is the each and every process according to the category. For vector, it is buffer. Buffer means we will buffer means creates a zone around a feature. Feature means points, lines, and polygons, or commonly referred as feature. So a particular zone will be created around it. For example, we create a 500-meter buffer around highways to identify schools that flat within that zone. We will create buffers near for flood-prone zones. We will create buffer only. So it used for proximity analysis like environmental impact or service coverage, which part will coming under where like this. Then clip. Clip is like a cookie cutter. It trims one layer using boundary of another. For instance, we can clip urban area data to a particular district boundary to focus only on that particular specific area. This we'll often do this while we are selecting our study area. Then intersect. It finds in overlapping regions between two layers. So common example is overlaying flood zones with build-up areas to identify the vulnerable settlements. Then comes our dissolve. This merges adjacent polygons that share a common attribute. For example, if we had land parcels classified by land use type, we can dissolve all agricultural areas into one continuous polygon. Then our network analysis that helps to understand the connectivity and movement. This is used in the, here we can use the shortest route analysis for the nearest hospital or emergency shelter, wherever we want. Then comes our raster calculator. This allows us to perform mathematical operations on raster layers. For instance, we can combine rainfall and elevation data to generate index or hazard map. Then zonal statistics. So this calculates the statistical values like mean, sum, standard deviation like this for a raster dataset within the vector zone of a raster dataset within the vector zone, that is a satellite image within the boundary. A good example is calculating average NDVI for each land cover class in our boundary. Then heat map. This converts point data into continuous surface to visualize the density pattern. So this is how we have been using all the functions in our work. So mainly buffer clipping and overlay is the core and repeat analysis in any part of research, any part of GIS project. I hope you guys understand this well. Any doubts in this concept? Should I have to repeat anything? Let's see a quick summary. We just have seen what is GIS. It is a system to collect, store, analyze, and visualize the spatial data for informed decision making. Then we learn about the types of data, that is vector, which is discrete data, point, lines, and polygons. Raster, it is gridded surface with pixels. It is about continuous data. Then coordinate reference system, it defines how real world locations are mapped for accurate spatial alignment. We will see the data management tomorrow. Then our spatial analysis, apply GIS tools to explore patterns, relationships, and trends in each research. You guys are clear? Any doubts? Anything I have to explain again? If you have any questions, kindly ask me. I'll clarify it. Or if you want to cover me anything, just tell me, I'll cover it tomorrow. Any specific topics? You want me to cover any specific data set? Can we have a warm-up quiz? Could you guys just ping what are the two data types we have seen today? Raster and vector. It would be better if others also give me the answer. What are the types of data in raster? What are the types in vector? I mean, what is exactly is raster and what is exactly in vector? I hope everyone understood. It would be better if you give me some answers or some feedbacks about today's session. Yeah, that was exactly right. It was continuous phenomenon with the was discrete data. Thank you for your patience. And any questions from your end? Exactly. Thank you. Any questions? Thank you for all your answers. Which software we have to install? Actually, QGIS itself is a software. You can just go to the browser and type QGIS. I will give you the link to download. Just give me a second. QGIS. I'll share you the link. You just copy it and just paste it in your browser. And I prefer to download the QGIS version 3.40. The current version is 3.44, but long-term version is 3.40. Okay. So kindly download 3.40. This is the link to download QGIS. Any other questions? All clear? Okay, if the session was good, you guys can drop some feedbacks in the chat box.
Hello. Thank you, Hamsudani, for today's session. And I believe
Okay, sir.
it is an interesting session for the rest of the peoples as well. And maybe I think some of them will voluntarily come forward and give some comment on your today's sessions. And
Yeah.
if they don't mind, anyone, please turn on your mic and give your valuable feedback so we can improve our sessions. Okay. Please, anyone.
In raster representation, what was the parcel? Sorry, I can't understand your question. Could you elaborate it, or you can turn on your mic? Even if in chat also, no problem. Raster representation, what was the parcel means? Like in the vector data, I mentioned like .shp file, shx, that you're asking, or the boundary, or you're asking.
Hello everyone. I think there is no further question from the students yet. So maybe okay. Hamsadini, there is one more question from Joe Anthony, and after that we can finish our today's session. Okay.
Okay, so yeah, he just asked me to explain about plugins. Okay, I'll explain it. So plugins are like apps within apps. We can perform other analysis easily through our plugins. So commonly used plugins I have mentioned earlier, that is semi-automatic classification plugin, SCP plugin. This is for satellite processing. Then comes our quick map services. This is for base map addition. First thing is semi-automatic classification plugin, that is SCP plugin. This we mainly use for satellite image classification in any GIS project. Then our quick map services. This is to add base map like Google Map, Google Satellite Map, Google Satellite Hybrid. We can add those maps in our background. Then we can overlay our particular study area. Then third thing is our time manager. This is to animate the temporal data. 2010 data, 2012 data, likewise temporal data. These are the three plugins I have mentioned, but there are a lot of plugins to explore. You can also integrate this QGIS with other GIS engines like GrassGIS, Saga, and GDAL. This is also found in the toolbar, processing toolbar. Is it fine? You clear? I'll show you how quick map services work in tomorrow's session for sure. Okay, because it will be starting from there. Okay, thank you. Thank you so much. Okay, sir, I hope every questions was done. Thank you for all your feedbacks. Sir, I hope we can wind up today's session.
Okay, thank you, Hamsudani. So we can wind up for today, and maybe we will have our another sessions tomorrow at the same time, 7:30 p.m. IST, and every one of you can use the same link for tomorrow's sessions as well. Okay. Okay. Good night.
Okay, sir.
Yeah.
Thank you.
Thank you. Thank you. Thank you all. Thank you all.